Hello everyone, let us learn about the Clemmensen reduction. Okay, so this is from the organic chemistry of class 12th from the chapter Aldehyde, ketones and carboxylic acid. Now when we study about the Clemmensen reduction, we will start with the aldehyde or ketone. Okay, so here I have taken ketone and the name of the ketone is propanone. How do we know this is ketone? Because we have to select the carbonyl group first. CO is called your carbonyl group. Okay, carbonyl carbon, and now this carbonyl carbon is directly attached to R, that is carbon. Here it is carbon, so this is ketone, and the name of this ketone is propanone. Why? Because it has 3 carbon, 1 2 3 carbon chain, so propanone. Okay, ketone, so propanone. Now what is the reagent of this reaction? That is zinc amalgam in presence of acid, that is hydrochloric acid, and it has changes into alkane, corresponding alkane. We have started with what number of propanone carbon chain? 1 2 3, and what we got here? We get here 1 2 3, so this is propane. Okay, so that means propanone has changed into propane. Okay, so whenever we study any reaction, first of all what we need to know is that what is the starting material. We should know what is the starting material for this reaction, or what is the starting compound for this reaction. Okay, we know the starting compound should be either aldehyde or ketone, any aldehyde or ketones. Now then we have to know what is the aim of the product. What is the aim of the product of this reaction? Then from this reaction we came to know that the product should be propane or alkane, corresponding alkane, and we have to know what is the suitable reagent for this reaction that is required, that is zinc amalgam in HCl. So whenever you study any reactions, always compare the changes here. So we have started with propanone, and what changes came here? There is oxygen. When it came to the product, there is no oxygen here, oxygen has removed. Now then we brought here 2 oxygen, that means we have removed oxygen and by replacing with 2 hydrogen. So what we know, that removal of oxygen is called reduction, or addition of hydrogen is also called reduction. So this is reduction, and the name of this reduction is called Clemmensen reduction. Okay, so we have started with propanone, which is a ketone. So we can also start similarly with the aldehyde. Let's take a simple aldehyde, CH3CO. Now when we want to talk about aldehyde, there should be CHO. Okay, CHO. So this is aldehyde. How many carbons? There are 2 carbons, so this is called ethanal or ethanol. Same reagent, zinc with Hg amalgam, that is in presence of HCl. Then will change into what? Your oxygen will has to be removed, so CH3C, and we will replace by 2 hydrogen. Initially there is hydrogen, so this is the product. So now ethanol into ethane, so corresponding aldehyde or ketone into corresponding alkane. Okay, so this is the aim of our reactions. So what is Clemmensen reduction? That means your conversion of aldehyde or ketone into corresponding alkane with the help of suitable reagents, that is zinc amalgam in presence of HCl. So now let us make it more clear by learning the mechanism. So we will now write the mechanism. So what is mechanism? Mechanism means showing the path where the reactants convert into the product. Okay, so we will start with our starting material is what? Let us take with the ketone CH3COCH3. Okay, now we will take zinc. Okay, zinc is a metal and it loses electrons, so zinc will convert it into Zn2 plus, will convert into Zn2 plus by losing 2 electrons. Okay, now let me write these 2 electrons here once again. These 2 electrons will try to attack this carbonyl carbon. Okay, so you might ask, this is also carbon, this is also carbon, why this 2 electron has chosen this carbonyl carbon? The main reason behind this is that this carbon is reactive carbon out of these 2, because this carbon is attached to the electronegative atom oxygen, where it has the tendency to pull the electron towards itself, and this carbon will attain some partial positive character, and this will attain some partial negative character, so these 2 electrons will try to attack this carbon center. Okay, so now oxygen being electronegative will pull the electron towards this oxygen. As we know, in a bond there are 2 electrons, one belong to carbon, one belong to oxygen. As it has pulled, it has shifted this this electrons toward itself. Carbon is losing 1 electrons. So now, but still the 2 electrons is providing here. Now it will change into CH3. C, oxygen will become single bond now. Okay, so pulling the electron towards itself, so gaining electrons, 1 electrons. Now carbon is losing 1 of its electron. It is balanced by another electrons, but still the carbon is gaining extra electrons. Okay, 1 electrons balance, another electrons, so negative. Now CH3. Okay, now I'll bring the arrow here. Now HCl, in the solution there is HCl, hydrochloric acid, so HCl will release out H positive, so numbers of H positive. So oxygen being negative in charge will try to attract this H positive. Another carbon being negative also will try to attract this positive, and now it will convert into CH3, C, H, O, H and CH3. Okay. Now again, from the solution H plus, from where this H plus? From HCl. Okay, H plus from HCl. Okay, now oxygen having its lone pair will try to attract this H positive, and now it will change into CH3, whatever there, just write it, CH, whatever here, CH, then CH3. Oxygen, initially there is 1 hydrogen, it has attract another hydrogen, so it will become as H positive. Okay, now H positive because it has already bonded with this H plus proton. Now oxygen being positive is very unstable, so it will like to become stable, so it will like to attain stability by gaining this 2 electron towards itself. Now CH3, okay, whatever there, just write it, CH3. Now this has gone out as H2O. So the carbon is losing 1 electron, so positive sign, losing 1 electrons. Okay, because this bond there are 2 electrons, one belong to its, one belong to its. Carbon, 1 belongs to carbon, 1 belongs to oxygen. Since it has taken the 2 electrons, now carbon is losing electrons, so positive. Now once again zinc will release out 2 electrons, and these 2 electrons will be provided here, so these 2 electrons will attack here, and now CH3, CH, CH3. Okay, now there will be negative sign here. Again, from the solution there will be H plus. Okay, that from where? From HCl. This H will attack here, this negative carbon will try to attack this proton, and now it will change into CH, CH2, extra hydrogen proton came. Now it has changed into what? Propanone. So this is the mechanisms of the Clemmensen reduction, where we have changes from the propanone to propane, that means corresponding ketone to corresponding alkane. In this way we can write the general formula like this. So this is your what? This is your ketone. Okay, this is your ketone. So this is R means what? Carbon group. So if I put this Clemmensen reagent HCl, it will just change your carbonyl group into CH2R. Now I can write many other reactions, numbers of reactions, by changing this R. Okay, I can write CH3, CH2. The same thing it will be there here. CH3, I have changed this R with CH3, put the reagent zinc amalgam with HCl. Now it will just keep whatever remaining, just keep what as it is. Okay, only changes will bring here CH2, CH3. Changes has brought up where? From here. Okay, only to this carbon. Everything what is there here, the rest will remain the same. Only changes where? In this carbonyl carbon, it has changed into CH2 group. Okay.